computer, share screen. Okay. Sorting algorithms. So the sorting algorithms homework can be done is one of your first ones that can be done in any programming language. In fact, I highly recommend choosing whatever you're most comfortable with and going to Rosetta Code. And I'll just try to go through this as quickly as possible. Okay, go to Rosetta Code, and you can find basically a write-up of basically any algorithm you need in here. Let's go ahead and take a look at, let's see. Oh, sorting algorithms, bubble sort. Yeah, that sounds great. Because bubble sort isn't one of the ones you can do, but whatever. You can grab anything from here. Just be sure if you grab any sorting algorithm from online, you got to cite it so I know where it came from. It's just, it is the correct thing to do in an academic setting. And in general, you want to cite where it is so you don't give the false impression that it's the code you did. Take the code and then modify it. So for instance, here is bubble sort. Okay. Now, what you want to do with the sorting algorithms is that you're going to choose 3 of them. I've got a selection for you. Or sorry, I've got a selection of them for where you get some choice in it. And what you're going to do is you're going to modify this algorithm to keep track of the number of exchanges and the number of comparisons. A comparison is whenever you would use essentially a compare to statement or see if things are out of order. It's not when you're checking to see, okay, have we ended the loop yet, right? This is not running this for loop over here. A is less than comparable dot length -1. Checking to see if you're done with the loop is not a, or checking if the index is done with. That's not a comparison in terms of sorting algorithm. A comparison is when you're trying to see if 2 things are out of order. Okay, so that's a comparison. An exchange is when you swap 2 data elements, when one thing moves to another place. Okay, so those are the 2 things you're going to be measuring. So you're going to want to modify your sorting algorithm to keep track of that. Now, I suggest 2 ways. First is modifying your algorithm so that they either return or take in, and take in is probably easier for your recursive algorithms, a data object. And a data object simply is an object you make. It simply has 2 fields, number of comparisons, number of exchanges. And whenever you do one of those, you just simply do data dot whatever plus plus. And then at the end, you return that data object, and then you're done. No problems there. You don't want to just print it out, as you'll see, because we're going to be collecting these things. Okay, so for these, I want you to implement insertion sort, quick sort, and one other algorithm that's listed below, which is shell sort, merge sort, heap sort, or Tim sort. Okay, each of these are chosen for an interesting reason. Shell sort, heap sort is interesting because it has applications for not sorting the entire problem, but for doing like subsection sorting and that kind of stuff. Merge sort is because that was kind of the default before Tim sort, and Tim sort's built on that. Shell sort because, as I mentioned previously, it's an unanswered question as to what the optimal runtime for shell sort is. Tim sort because that's currently what is used as one of the state-of-the-art algorithms in sorting, just for sorting general data. Again, we also want you to check how much time it takes, but that's a lot easier because you just simply check what time it is before you start the run, and then check what time it is for immediately after you're done, and subtract the 2, and voila, you now have how much time it takes. So what we want you to do is essentially graphic this in Excel. Specifically, what we want to do is that we want to test this algorithm on different size lists or lists of integers. Okay, so a good test will have a lot of data points of varying magnitudes. For example, a decent test might have test lists that are sizes of powers of 2. Okay, sizes that are powers of 2. Sizes that are power of 2. Sizes that are powers of 2. Not items that are power of 2. I had this problem last semester. I don't want sizes. Your size of the list goes up. Do not test your algorithm on lists of size 10 over and over again. I want them to be size 64, size 128, size 256, size 1024, and you should be able to see with a quadratic algorithm that you get a quadratic curve, right? Because each time you double it, it's going to take 4 times as much time. Sorry about that. That happened a lot last semester. It's a bit of a sticking point for me. And because it just made, because a lot of students did that, and then they realized, oh, I actually still have a lot of work to do, because they thought they were done and then moved on to other things, and then demoed it a couple of weeks after the due date, and they're like, oh, I wasn't done with that at all. So size is a power of 2, please. Or if you want to, size of the power of 10. Try it on a size of list 100, then 1,000, then 10,000, then 100,000. That might be harder to see and harder to run, but if you want to do that. The idea here is that you're going to be collecting a lot of stuff. You can either output your data to a file. You want to output your data to a file. You can either do that automatically or manually, which just manually means just taking your data objects and printing them out and just copying and pasting them into an Excel file. Sorry about yelling there. It was just such a annoying thing last semester. It was like a quarter of the class. All right, so presenting your data. Fair enough. Sorry, a fair amount of freedom here with presenting your data. But we want it to be well formatted, either a very well formatted table that I can see easily what's going on. So like make sure that your times are right aligned, so I can see the magnitude of digits, so I can see, oh, that is orders of magnitude bigger. Graphing your data is a lot easier, and that's pretty good. So 20 points, 30 points, and 20 points for doing just implementing these algorithms, finding them correctly. Like, there's no reason anybody should get less than a 70 on this, because the way I've rubric this accidentally was, oh, right. So if I just copy paste the algorithms and cite them, that's 70 points. And so nobody should be able to but cite them, please. Okay, 15 points for collecting your data. 15 points for presenting that data in a meaningful way. Okay. And then you get 7 extra credit points if you choose TimSort as the third and final algorithm. Okay, so there you go. Again, this is a great place to look for your sorting algorithms. And again, you can do it in any programming language that you want, provided you can actually run it. Right? I don't recommend, as I mentioned earlier, I don't recommend doing hello, to use Hello World as an example. I don't recommend doing it in Ook, which is, let's see, do they even have it as Ook? No, they don't have it in Ook, which is sad. If figured they'd have an Hello World in Ook, and I'm not going to, oh yeah, okay, so let's see. And then BF, which is this language, wonderful. That language is this language is just composed of 8 different symbols. I'm not going to say its full name, but that's what Ook is based off of. Chef, category Chef, esoteric programming language that uses stacks. So esoteric programming languages are just things that are well, essentially they're I can't believe this is a thing. Wow. This is Hello World and Chef. Apparently that's and we can see that it's point over here, which is that looks like a recipe. There's a lot of different languages. Other languages of note that you may not have heard of are we go back to the ones that actually get used. We can see ones that are actually used because they exist in bubble sort, which is the worst sorting algorithm ever. Well, one of them, not the worst. Let me just one. NIM, which is an interesting programming language because of how it interacts with C and the fact that it allows you to do weird things that you would think that Python would allow you to do, but doesn't, like override the addition operator, or like declare, hey, this is what the addition operator does on my functions. Also, it allows you to use functions as either functions or as methods. It kind of removes that illusion. It's a very interesting language. I looked into learning it a bit ago. Scratch is interesting, but and I'll be interested to see if anybody can actually do like merge sort in Scratch, which is a visual programming language that's done in blocks. Scheme and other Lambda-based functional programming languages. I think the popular current popular functional language though is Haskell though. I mean, I know, and then finally Go, which is Google's programming language, which is very interesting. Especially with the way they do something. They have the walrus operator over here. And what the walrus operator, and I just like to point this out, the walrus, Go is a strongly typed programming language. So you would normally, so you have to declare that this list is an array of integers, which is done over here, array of integers. But this walrus operator allows you to simply say, computer, figure out what the proper typing is, and we'll just simply strongly type it as that. It makes a lot other. Also, the weird thing about Go that makes it different is that the variable name goes first, and then the type declaration goes later because reasons. They have a compiler reason for it. Makes their compiler work better for their purposes. There's a lot of different programming languages out there. I hate them all equally. There's in the words of Bjorn Strusup, the creator of C++, there are two types of languages: the types of languages people complain about, and the types of language that nobody uses. So keep that in mind. Every language is wonderful. Every language is horrible. If you want to really wail on JavaScript, you can take a look at Destroy All Talks JavaScript. Their WAP talk specifically, that one is worth a 5-minute watch. In which they show you which was a live presentation for about 5 minutes of all the idiosyncrasies of JavaScript. It's kind of amazing if you know JavaScript, and it's kind of amazing if you don't know JavaScript. So worth taking a look on. All right, so I've wasted enough time. Again, sorry for yelling about the sizes. It got a bit loud there, but hey, now hopefully you won't forget. No worries, I won't be mad if you miss it. I will just simply be, yes.
Out of curiosity, how much extra credit are you willing to reward if anyone manages to pull off a full sorting algorithm from scratch?
Award? Award? No. I'll be impressed. I'll be impressed for sure, but I don't know if it's necessarily a good use of time. All right, so what I'm gonna do now is I'm gonna enable screen sharing, and I'm gonna so if you want to meet about